Hey guys, welcome back to another RASK math tutorial, and in this tutorial I'm going to be showing you guys how we can calculate the distance between 2 points in 3D. So to calculate the distance between 2 points in 2D, let's say for example I have the point 2, 1 and 5, 4. So to calculate the distance between these 2 points, just 2D points, it's pretty simple. We have to use Pythagoras' theorem. So what we do is we construct a triangle between these points, which in this case the triangle would have height 3 and length 3 as well. It's not actually to scale, but there we go. And we can say the distance is just going to be equal to, well, using Pythagoras theorem, we know distance squared is going to be 3 squared plus 3 squared. So if we just take the square root of both sides, that's going to give us the distance is the square root of 3 squared plus 3 squared, or 3 root 2. So that's how you calculate distance between 2 points in 2D. Now let's just do the same sort of thing in 3D. So I'm going to draw myself a 3D system like this. And let's say we have a point here at, I'm going to say 1, 1, 2. This is the x, z and y axis. And let's say we have another point over here. I don't know. Let's have 3, 4, 5. Okay, so how are we going to calculate the distance between these points? Let me denote it with that line. Well, what we need to do is first we need to go along in the x direction, like so. Then we need to go along in the y direction, like so. And then we go in the z direction, like so. So what this comes down to is there are two separate triangles. So first I'm going to expand out the xy triangle, or this is the triangle in the xy plane. And it's going to look like this. And to be specific, it's this triangle here. So the xy triangle, well, it's going to have a base of 2 and a height of 3. See these distances there. And then we can work out this distance here. I'll just call this, let's call this A for now. This distance is just going to be square root of 2 squared plus 3 squared, because we've taken everything on one plane, so now these are essentially just 2 points, and that's equal to the square root of 13. Then what we do is we have this distance here, and we want to make a new triangle. So this triangle, which isn't in one particular plane, I'll try and demonstrate. It's in this plane here, so there's no specific plane, but I'll just call this triangle number 2. We use the length we just calculated, which now is going to be root 13 here. And we also have to get this height, which is just going to be a difference in z, so that's going to be 3. And what we can do is, I'm just going to call distance d. We take the distance between these 2 points as if they were 2D again. So root 13 squared is 13 plus 3 squared, and that's going to be equal to root 22. So therefore, the distance between these 2 points, let's just say 1, 1, 2 and 3, 4, 5, is root 22. So that's basically how you work out distance in 3 dimensions. You just split it into the bottom triangle, normalized to one plane, and then you take that length and put it onto another triangle, which is another plane, and that should give you the overall length. Now what you notice is that this root 22 is the same as just taking a sort of extended version of Pythagoras. So this difference between the x-coordinates, 2 squared plus 3 squared plus 3 squared. And that should make sense because what we did was we took the difference between these two in this plane and then squared it. So you can see the square and square root cancel out, especially we don't have to worry about negatives because these are all lengths. And all in all, that just leaves us with root 22. So there we go. To work out the distance between 2 points in 3D, we just use an extended version of Pythagoras. Just take the difference between each component and then square each one and take the square root of their sum. Now, it's actually interesting to note that this works in further dimensions since we're doing the same kind of thing, and it's all because of this property where we square it and then, or we square root it and then square it. So if you had 4D points, 5D points, it's all the same thing, and it's not that useful for working out the distance between two specific points, but it's really useful for working out magnitudes of vectors, because vectors can often be much more than 2 and 3 dimensional. So thanks for watching, and that was how to work out the distance between 2 points in 3D. See you guys in a future tutorial. Bye.